Everyone, welcome to Data Science Community. In today's video, we are performing one more data analysis project. Basically, it is a whole machine learning project. Okay, so we are performing this project in two parts. In first part, we are going to discuss a data set and doing analysis of this data set. And in our second part, we are train our model and apply some of the model which is suitable for our data. Okay, so let's start. So in this part we are performing data analysis, exploratory data analysis, feature engineering. Okay, so this is our Jupyter Notebook and this is our Bitcoin price prediction project. Okay, so first and most important is to importing all the libraries which we want. Okay, so here we are importing NumPy, Pandas, Matplotlib, Seaborn, sklearn.model selection. So basically these from here to here we are using in our second part. So in this part we are only using this much libraries, which is NumPy, Pandas, Matplotlib and Seaborn. Okay, and remember how we are using these libraries. Okay, and next is here we are importing our dataset. Okay, so the dataset will be used to so the dataset which we use here to perform the analysis and build a predictive model in Bitcoin price data. Okay, and we will use open, high, low and close. Okay, which is basically the price of Bitcoin, lowest price, highest price, open price and close price of each day. Okay, and the data is from 17 July 2024 to 29th of December 2022. Okay, which is for 8 years. Okay, for Bitcoin price. Okay, so basically our data set is for last 8 years. Okay, so it will having up Bitcoin price for 8 years. Okay, so here in next cell here I am importing my data set which named as bitcoin.csv. Okay, this is my file name and here I am reading it by using pandas function real_csv, and here I am showing my data set by using head function. Okay, so basically head function will return the first 5 rows of our data set. I already make a separate video on pandas function which is useful for data analysis and machine learning projects, so you can go and check it out, that video also. Okay, so let's move ahead, and this is our data set. Okay, so basically here we have date, open, price, high, low, rows, adjacent, close and the volume. Okay, so in next cell here we are finding the shape of our data set. So as you can see here we are storing our data set in df instance, and here I'm checking the shape of df. So as you can see here we got to know that there are 2713 2713 rows of data available, and for each row we have 7 features. Okay, so this is our shape of our data set. Okay, and next here we are using describe function which will print the descriptive statistics of our data set. Okay, this describe function return the descriptive statistics of our data set. Here we have count, mean, standard deviation, minimum value, 25% values, 50% value and 75% value, and the maximum value of our data set for each column. So describe function is only used for numerical columns, and if you want to use it for categorical columns you need to write include equals to all. Okay, but we don't have our categorical values in this data set, that's why here I'm using only describe function. Okay, and here we are using info function which will print the information about our data set. Here it will print the column name, rows and the data type of the respected columns. Okay, and next let's see what is exploratory data analysis. Okay, so exploratory data analysis is an approach to analyze the data using visual techniques. Okay, so here we are analyzing data by using visuals. It is used to discover trends, patterns or check the assumption with the help of statistical summaries and graphical representations. Okay, while performing EDF of the Bitcoin price data, we will analyze how prices of a cryptocurrency have moved over a period of time. Okay, and how the end of the quarter affect the price of that currency. Okay, so let's start our exploratory data analysis. So first we are plotting a graph for closing price. Okay, so here you can see that the price of a Bitcoin stocks are showing an upward trend as depicted by a plot of closing price of the stock. Okay, So you can see here the closing price is high or upward, you can say. Okay, so here I'm using plt.plot. Plt stands for matplotlib.pyplot. Okay, and here I'm writing my y label, which is written here. Okay, and here we use plt.throw to print this graph. Okay, and here I'm checking whether my close column having the equal value with the adjacent close. Okay, so here, as you can see here in our data set, we have two columns, close and adjacent close. So you can see here both the column having the same values. Okay, so here I'm writing a code for checking whether. Okay, so that's why both the column having same values. So that means our data is having redundant values. Okay, our data is redundant. So for that, we are not going, this will not help us. So we need to drop one column. So in next cell, okay, in next cell, here I am dropping my adjacent close column. Okay, so here I am using the drop function for deleting this column from my data set. Okay, or you can check it by just, you can see here the adjacent close column is removed from my data set. Okay, now let's check there is any null value present in my data set or not. Okay, so here I'm using isNull function, and .sum is used to sum up the all null values present in each column. Okay, so there is no null values present in my data set. Okay, now I'm just plotting a separate plots. Okay, basically this is an box plot. Okay, for finding if there is an outliers present in my data set or not. Okay, so as you can see here, there is so many outliers present in each column. Okay, so open, high, low and close all were having so many outliers. Okay, so which means that the price of a stock having varied hugely, okay, in a very short period of time. Okay, so which means our stock value is increasing at a very short period of time. Okay, so now let's just separate this date, and if I want to create a separate year, date and day column, month and day column, so for that I'm splitting my date columns value with this. Okay, so for that you need to use this split function, which is a string function. Okay, so and if you are using this function, it will store the date, year at first index, month at second index and day at third index. Okay, so it will separate the values and on the basis of this sign and store each values in a form of list. Okay, so basically it will form a list of, for example, 2014. Okay, comma, my month is 9 and next my day is 17. So it will store the value like this. Okay, so it will store this value like this. Okay, and create a separate column. Here we are using this splitted instance, which we are using here to store splitted values. Okay, so in splitted value at index 0, which is our year. Okay, we are storing it at first index, and month, and similarly we are storing the day. Okay, so that's how we are creating these three columns in our data set. Okay, so here you can see that year, month and day column is created. Okay, previously these values were not present in our data set, as you can see here. Okay, now let's check the, so all these three have been derived from the date column. Okay, which has initially provided in the data. Okay, so now we are checking the Bitcoin price on the basis of each year. Okay, so here we are seeing that we are grouped by the data on each year. Okay, and finding the mean of each year, we are grouped by the data on the basis of each year. We are finding the mean of the values present for each year. Okay, and here we are applying loop for our 4 columns present in our data set. Okay, and we are plotting a graph for each of these columns. Okay, so here you can see that in year 2021 we have the highest stock price. Okay, as you can see here in year 2021. Okay, so here we are observe why there are so many outliers in the data, as the price of the Bitcoin is exploded in the year of 2021. Okay, so you can see here the growth is less till 2022, and there is a increase in the price of Bitcoin in the year of 2021 and 2022. Okay, there's huge difference between these values and this value. Okay, so that's why we are having so many outliers in our data set. Okay, so now let's see here we are creating one more column, which is quarter end. Okay, here we are using np.where the month is divisible by 3. Okay, we are storing the value of is quarter end as 1. If the month value is not divisible by 3, then we are storing 0 at that place. As you can see here, 9 is divisible by 3, that's why here the 1 is present. Okay, and the 2 is not divisible by 3, that's why here 0 is present. Okay, so basically this was the, if you are familiar with SQL, then you know what is where, group by. Okay, these commands are used in SQL on the initial. Okay, so if you are applying for data analysis or any developer post or any technical IT post, you should know about SQL. Okay, and I already make one video on SQL and select command on SQL. If you want, you can go and check it out, that video also. Okay, and now here I'm making one more column, okay, in my data set, which is a target column. Okay, so this is my target column. So basically in this target column I'm showing whether you should purchase the bit or not. Okay, so here I am creating one more column, which is open minus close. Okay, we are finding open minus close, which is the opening price of the Bitcoin and the closing price of Bitcoin, and we are also subtracting lowest price and highest price. Okay, and we are making target column by just subtracting close minus 1 with close. Okay, so this code create a new column named target. So here we are creating new column which is named as target. Okay, and in the data frame, okay, df, which is named as df. Okay, where the value in a target column are determined by comparing the current row. Okay, for example, this is our current row close value with the next row. Okay, next row close value. If the next row close value is greater than the current row close values, okay, so then the target value is set to be 1. Okay, otherwise it is set to be 0. So as you can see here, this value is less than this, that's why here 0 is written, and you can see here this value is less than this value, that's why 1 is printed here. Okay, if the stock price is increasing, then it will good for you to purchase, and if the stock price is decreasing, then you should not. Okay, so that's how we are making our target variable. Okay, so we have added the target feature which is a single. Okay, whether to buy or not. Okay, we will train our model to predict this only. Okay, so we are making our model, we are training our model to predict this only, whether you should buy it or not. Okay, but before proceeding, let's see whether the target is balanced or not using pie plot. So here we are plotting our pie plot on the basis of target. So we have 54.1% no and 45.9 as 1, which means you can purchase the stock, or you should not purchase the stock values. Okay, so that means our data is balanced. Okay, so here we are finding whether our column is correlated with each other or not. Okay, so from this heat map, this is known as heat map. Okay, so we can say that there is a high correlation between OHLC, which means open, high, low and close. Okay, and the edit features are not highly correlated with each other or previously provided feature, which means that we are good to go to build our model. Okay, so basically you can see here our newly created columns are not that much correlated with each other, but our initially provided columns were correlated with each other. That means it is a good for us to go with this data. Okay, so in next part we are going to train our model, and we are applying different machine learning algorithms on our model and finding best algorithm to predict whether we should buy our Bitcoin or not. Okay, So that's all for this video. Thanks for watching. Like, share and subscribe for more such videos.